As the COVID-19 pandemic swept around the world early this year, shortages of protective equipment such as N95 masks left healthcare workers little choice but to reuse the mask they had, increasing the risk of infection for both them and their patients. Now, researchers at the Department of Energy's SLAC National Accelerator Laboratory, Stanford University, and the University of Texas Medical Branch may have a solution. Using a combination of moderate heat and high relative humidity, the team was able to disinfect N95 mask materials without hampering their ability to filter out viruses. It should not be too difficult to turn the new results into an automated system hospitals could use in short order. Because the process is so simple, it might take just a few months to design and test a device. The team reported their results in the journal ACS Nano. Facing a shortage of the mask early this year, researchers considered a number of ways to disinfect them for reuse, including ultraviolet light, hydrogen peroxide vapors, autoclaves, and chemical disinfectants. The problem is that many of those methods degrade N95 masks' filtering abilities so that at most they could be reused a few times. In the new study, the researchers focused their attention on a combination of heat and humidity to try to decontaminate masks. Working at the World Reference Center for Emerging Viruses and Above-Viruses, which has biosafety measures in place for working with the most contagious viruses, the team first mixed up batches of SARS-CoV-2 virus in liquids designed to mimic the fluids that might spray out of our mouths when we cough, sneeze, sing, or simply breathe. They next sprayed droplets of the brew on a piece of melt blown fabric, a material used in most N95 masks, and let it dry. Finally, they heated their samples at temperatures ranging from 25 to 95 degrees Celsius for up to 30 minutes with relative humidity up to 100%. Higher humidity and heat substantially reduced the amount of virus the team could detect on the mask. Although they had to be very careful not to go too hot, which additional tests revealed could lower the material's ability to filter out virus-carrying droplets. The sweet spot appeared to be 85 degrees Celsius with 100% relative humidity. The team could find no trace of SARS-CoV-2 after cooking the mask under those conditions. Additional results indicate masks could be decontaminated and reused upwards of 20 times and that the process works on at least two other viruses, a human coronavirus that causes the common cold and the chikungunya virus. The researchers said that although the results are not especially surprising, researchers have known for a long time that heat and humidity are good ways to inactivate viruses. There hadn't been an urgent need for a detailed quantitative analysis of something like mask decontamination until now. The new data provides some quantitative guidance for the future. And even after the coronavirus pandemic is over, there are likely benefits, in part because of the method's application beyond SARS-CoV-2 to other viruses, and because of the economic and environmental benefits of reusing masks.